Have you ever wondered about the mysteries the universe holds? What if we told you that one of the most spectacular cosmic fireworks is a supernova? Our universe is an enigmatic expanse, a cosmic tapestry woven with a myriad of mysteries, one of which is the awe-inspiring phenomenon of supernovas. These celestial wonders are not just beautiful to behold, but they also hold the answers to many questions about the universe and our existence. You see, a supernova is not just any cosmic explosion. It's the cataclysmic end of a star, a cosmic finale that outshines entire galaxies. Yet, amidst this mesmerizing spectacle, the birth of new stars and the forging of elements essential for life take place. It's a complex yet fascinating interplay of life and death, creation and destruction that unfolds on an astronomical scale. So a supernova, in essence, is the explosion of a star. But what causes this colossal detonation? Let's dive in. A star, much like our very own sun, doesn't just explode out of the blue. It's a process, a fascinating one at that. Let's dive into the mesmerizing cosmic dance that gives birth to a supernova. The life of a star is a constant fight against gravity. From the moment it's born, a star is under immense pressure, both literally and metaphorically. Its own gravity is always trying to squeeze it into the smallest, densest point possible. But the star has a secret weapon: nuclear fusion. It's the process that powers the star, creating heat and light, and it also creates an outward pressure that balances the inward pull of gravity. Stars burn hydrogen in their cores, fusing it into helium. This process releases energy, which is what makes stars shine. However, like all good things, this hydrogen fuel doesn't last forever. When a star exhausts its hydrogen, it starts burning heavier elements, like helium, carbon, and oxygen. Each fusion process releases less energy than the last, and the star has to burn at higher temperatures to keep going. Ultimately, the star starts producing iron in its core. Iron is the end of the line for a star. It doesn't release energy when it fuses, so it doesn't provide the pressure needed to fight against gravity. The core becomes dense and heavy, and the star can't support its own weight anymore. It collapses under its own gravity in a fraction of a second, and the rest of the star comes crashing down. But here's the twist. The core is so dense that the falling material can't get any closer. It rebounds, creating a shockwave that races outwards, tearing the star apart in a brilliant explosion. This is a supernova, one of the most powerful events in the universe. So essentially, a supernova is a star meeting its dramatic end. But what happens after the explosion? That's another story. The aftermath of a supernova is as fascinating as the explosion itself. It's not just an end, it's a beginning too. When the blinding light of the explosion dims, the remnants of the star begin a new journey. The core, once the heart of the star, collapses under its own gravity and forms a neutron star, or, in some cases, a black hole, entities that are as enigmatic as they are powerful. But the story doesn't end here. The explosion also disperses a rich soup of elements across the vast expanses of the universe. These elements, some of which are only formed in the intense heat and pressure of a supernova, voyage across space, seeding the cosmos with the ingredients for new stars, planets, and perhaps life itself. This cosmic recycling is the universe's way of creating from destruction, a testament to the cyclical nature of existence. And in this spectacular cosmic cycle, the end of a star marks the birth of new celestial bodies. So, what have we learned about supernovas today? Supernovas are the grand cosmic explosions that mark the end of a star's life cycle. They are the universe's way of recycling matter, transforming a dying star into a brilliant spectacle of light and energy. The process begins with the star exhausting its nuclear fuel, leading to a dramatic collapse under its own gravity. This sets the stage for the main event, the supernova explosion. This cataclysmic event releases an incredible amount of energy, outshining entire galaxies for a brief moment in time. The explosion propels a shockwave into the surrounding space, dispersing elements forged within the star's core. And the aftermath? It's just as fascinating. The remnants of the supernova can form nebulae, pulsars, or even black holes. These remnants seed the universe with the elements necessary for life, proving that every end is indeed a new beginning. In the grand scheme of the universe, supernovas, these stellar fireworks, play a crucial role in shaping galaxies and making life as we know it possible. Isn't that something to marvel at?